Yo, 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 we got the Unit 4 test review. This is Part B. Here we go. Part B, number 7 says, circle all the congruent triangle pairs, then state by which postulate or theorem, we call those shortcuts, but postulates are theorems that proves them congruent. All right, here we go. Well, the first two, I see a congruent pair of angles. That match up with these angles. So those two triangles, we would say AA, but is there an AA theorem? And the answer is no, no. Nay, nay, there is no AA. Just for a little reminder, our theorems are, let's see, we got SSS, we got SAS, we got ASA, we got AAS, and for those right triangles, only for right triangles, there's an extra one that we could possibly use called HL. Alright? So having AA in a pair of triangles is not enough. It doesn't give us any of these 5 theorems. So AA, nay, nay. Not enough information is what we would say. There's not enough information to prove that those two triangles are congruent to each other. Let's move on. In the next pair, I see 2 sides. 1 pair of sides, 2 pair of sides. In fact, I see the same thing in both triangles. 1 pair of sides, 2 pair of sides that are congruent to the other triangle. Now, I see the 2 sides, and I also see 1 angle. But you have to decide. Does that A that represents the angle, does that go between the 2 sides? Is it sandwiched? Is it included between the 2 sides? And the answer is no. It is outside the 2 sides. So it's an angle side side. An angle side side is not one of our theorems. So again, not enough information. We had an AA, that wasn't good. We had an angle side side, that wasn't good. Moving on. In the next one, I got 1 pair of matching sides. I got 2 pairs of matching sides. I've got 3 pairs of matching sides. So that's 1 pair, 2 pair, 3 pair. That's SSS, and that's good. That's real good. So far we only had 1. Let's move on. All right, in the next one, I've got a pair of matching angles. I've got another pair of matching angles. And then I have the side here. And this side happens to be sandwiched between those matching angles. We say that that's included between the matching angles. So that would be a good example of ASA. And then here's ASA's cousin right next to it, where again, I have 2 matching sides. Whoa, rewind. I have 2 pairs of matching angles. All right. And then I've got the matching side. So I need to decide, is that side sandwiched between the 2 angles or not? And if you look at it, here's the side that's included between the 2 angles. That's not the marked side. Same thing over here. Here's the side that's included. So that side with the tick mark is not sandwiched between the 2 angles. So that would be AAS. So here's a really good example of the differences between ASA and AAS. They're similar, but they're just slightly different. All right. The next one is a right triangle. And I have a pair of congruent sides, another pair of congruent sides, and then I have 2 90-degree angles. And all right angles are congruent with each other, so I could put a little A there for angle. So you can see it just by looking at the triangle that is an SAS. SAS. If you weren't sure, well, we have 2 pairs of matching sides and the angle that's sandwiched between them. So here's the 2 pairs of matching sides, and you can see that angle is sandwiched between side, angle, side. Cool. You guys should be really good at this section. You should be like the best at that section because we've worked so hard on getting those figured out. You had a lot of practice. The next one says, does this diagram represent any congruent triangles? If so, which triangles are congruent? And I think so. I see a pair that jumps right out at me. I see the reflexive property going on here, so I'm going to mark this. Reflexive property. All right. I see more reflexive property too. Those two sides are congruent to each other. These two sides are congruent to each other. I guess I shouldn't have just used one tick mark there. That could be deceiving. Well, it's purple, so just know that it's congruent to itself. All right, so there's some stuff. Now, the first thing that jumps out at me is these two right triangles. All right, and then what jumps out at me is that they had matching hypotenuses, and then they had a congruent leg thanks to the reflexive property. So these two right triangles are congruent by HL. So the right triangle called ACF, so triangle ACF, which was the right triangle on the left, is congruent to triangle, if it's ACF, it has to match up with DCF, and they were congruent by HL. That's the first thing that jumped out at me. Now let's see if I can prove that anything else is congruent. Well, this triangle has a side and an angle that matches this triangle's side and angle. But that's it. It doesn't have any other matching parts. This side, I guess now that I've proven that these, okay, I guess I could say this now. Let me erase some stuff here. Since I've already proved that the bottom two triangles are congruent, now their corresponding parts can be proved congruent. But even then, this would be an angle, side, side. So I can't say that these two triangles are congruent because the only letters that I would have would be angle, side, side. So we can't have angle, side, side. So I cannot prove that triangle ABC is congruent to triangle DEC. Can't do it. That's why they're sad. I was only able to prove that the two right triangles were congruent. These guys. All right, and then down here at number 9 it says, list all the possible criteria for proving triangles congruent. Well, we already did that. We already did that. It's AS. It's SAS. It's ASA. Oops. It's AAS. And it's HL, which only works for right triangles. All right? It's never ASS or SSA, and it's never AAA. All right, you also can't have like AA or just SS or just SA. Those don't work either. All right, so here's the good ones. It's only 5. Not bad. Next. What additional piece of information is needed to prove that these triangles are congruent by angle, side, angle? Well, a lot of us missed this question on the quiz. We already have one of the angles. We already have one of the sides. So I need the other A. I got to have the other A. I've got the A, I've got the S, I just need the other A. And it has to sandwich the side, so I've got to say angle D is congruent to angle P. All right, it can be that easy. A lot of us missed that. Number 11 is the same way. What additional piece of information is needed to show that the triangles are congruent by SAS? Well, let's see. I have a side, I have an angle, but I don't have the angle that's sandwiched between the two sides. Side, side, angle. But again, I don't have the angle that's sandwiched between the two sides. So there's multiple right answers, but the easiest answer would be saying, hey, give me that angle that's sandwiched between the two sides. Give me that angle that's sandwiched between the two sides. If I knew that angle B was congruent to angle E, then I would know that the two triangles were congruent by SAS. So that's the quickest, easiest way to do it. Or you could have said, hey, dude, you've got the S, you've got the A. You could have said, if you had this other side, which is AC, congruent to this other side, DF, well, then you could have had your side, angle, side. Side, angle, side. All right, so either one works. I think that this way is better. I think this way is okay too.